This is the exam review for Honors Geometry for Unit 1, Topic 4. Question 31 says, every quadrilateral that is a parallelogram has certain properties. List all of these properties. Well, the first one we know is that a parallelogram, the opposite sides are parallel and congruent. We know that if we have our parallelogram, opposite sides are going to be parallel, otherwise it's not a parallelogram, but we also know that opposite sides are going to be congruent. We also know that opposite angles are going to be congruent. And with that property, if opposite angles are congruent, then we also know that consecutive angles are supplementary. Consecutive angles meaning angles next to each other. So these two angles are going to be supplementary and these two angles are going to be supplementary. Or you can look at it as these sets of angles are supplementary. So remember that if we've got parallel lines cut by a transversal, these are same side interior angles which are supplementary. Finally, our last property is about the diagonals. And the diagonals are going to bisect each other. So that means that this part right here is going to be congruent to this part because this diagonal cuts it in half. Same thing with this diagonal. This part is going to be congruent to this part because this diagonal cuts it in half. Question 32 says, what properties does a rectangle have in addition to those of a parallelogram? Well, we know that a rectangle is going to have all the properties of a parallelogram because our chart has parallelogram, and then we've got properties of a rectangle separate from properties of a rhombus, and then together they make up the properties of a square. So one of the properties of a rectangle is that all angles are right angles. So if we have our square, we know all four angles are going to be right angles. Additionally, not only do the diagonals bisect each other, but the diagonals are going to be congruent. So all four of these sections, like if this diagonal is congruent to this, and this bisects this one, this is congruent to this, which is congruent to this, which is congruent to this. So the diagonals are congruent. Question 33 says, what properties does a square have in addition to those of a rectangle? So now we've talked about the properties of a parallelogram and the properties of a rectangle. We have not talked about properties of a rhombus, but that's what we're going to add in order to get our properties of a square. So the first thing is a rhombus kind of looks like a parallelogram. It's not going to have the right angles. But one thing that we do know is that all of the sides are congruent, which is a property of a square. Additionally, on top of the property with the parallelogram about the diagonals bisecting each other, these diagonals are going to be perpendicular to each other. So they are going to bisect each other because that's a property of a parallelogram, but they're also going to form four right angles. Finally, the last property is also about the diagonals, and that's going to tell us that the diagonals bisect our opposite angles. So for instance, this angle right here is going to be congruent to this angle. This angle is congruent to this one. Now, we actually know that opposite angles are congruent, so we can say this angle is congruent to this one. This angle is congruent to its counterpart, I guess I should say, as are these two. So diagonals bisect opposite angles. Opposite angles are bisected by diagonals. And that gives us all the properties of a square when we include all the properties of a parallelogram, all the properties of a rectangle, and then these three. Question 34 says triangle DEF is isosceles with angle D is congruent to angle E. Which sides are congruent? So if we have a triangle and we label it DEF, always make sure you go in order, clockwise or counterclockwise, it doesn't matter. We know angle D is congruent to angle E. Well, we know that the angle and the side opposite are related. So if these two angles share the same measure, then their opposite sides must share the same length. Therefore, DF must be congruent to EF if this were an isosceles triangle. Finally, with question 35, we've got the figure to the right. We're told D is the midpoint of AB. So that tells us that AD and BD are congruent. And we know E is the midpoint of AC. So we know AE is congruent to EC. We also know AD is 8. And if we know AD is 8, then we know that BD is also 8. Otherwise, D would not be the midpoint. We are also told that BC equals 22. The ratio of AB to AC, so the ratio of this side of the triangle to this side of the triangle is 2 to 3. We're going to determine the lengths of EC and DE. Well, let's start with this information about the ratio. What we're told is that the ratio of AB to AC is going to be equal to 2 to 3. What we already know is what AB is, because if AD is 8 and DB is 8, AB must be 16. So 16 over AC equals 2 over 3. We're going to cross multiply. 16 times 3 is 48, and 2 times AC is 2AC. If I divide both sides by 2, I'm going to get AC equals 24. So if I know that AC is 24, so this whole length right here is 24, and E is the midpoint, then I know that AE equals EC, and I know that basically 2 ECs is going to equal AC. Well, if AC is 24, then 2 ECs equal 24. Divide both sides by 2. EC equals 12. So this is going to be 12, and this is going to be 12. So that's the first one we need to find. The length of EC is 12. Additionally, what we know is because DE is made up of the midpoints of the two sides, DE must be the midsegment of this entire triangle. If DE is the midsegment, then this length is half the length of the side of the triangle that it's parallel to. Therefore, we know DE is going to be half of BC, and that's because DE is the midsegment of triangle ABC. So if DE is half of BC, and I know that BC is 22, half of 22 is 11, and therefore DE must equal 11. Question 36 says, in the figure below, D is the midpoint of AB and E is the midpoint of AC. So if D is the midpoint of AB, then we know that AD and BD are congruent. And if E is the midpoint of AC, then AE is congruent to EC. We also know that DE is the midsegment. So this also tells us that DE is parallel to BC, and BC, the length of BC, is going to be twice the length of DE. So this is going to be 2 times DE. Or DE is going to be half the length of BC. So we're going to complete the statements using the items in the box on the right. Each item may be used more than once or not at all. So AD right here is congruent to blank. Well, since D is the midpoint, AD is going to be congruent to BD. AE right here is going to be congruent to EC because E is the midpoint. And blank is parallel to blank. Well, we know that the bottom sides of the triangle, the two sides that aren't bisected by DE, those are going to be parallel. So DE is parallel to BC. Additionally, we know that DE is 1/2 the length of BC. And we already talked about it. This is because DE is the midsegment, and that's one of the properties. Now the ratio of AB to AD is blank. Well, AB is this whole side, and AD is going to be half of it because we know that these two sides are congruent. So for every 1 AD, there's going to be 2 of them to make AB. Therefore, the ratio is going to be 2:1. Similarly, AE is going to be half of AC. So for every 1 AE, you're going to need 2 of them to make AC. Therefore, the ratio is 1:2. Question 37 says, if two parallel lines are cut by a transversal, which angle pairs are congruent? Well, we know alternate interior angles and alternate exterior angles are going to be congruent, and corresponding angles and vertical angles are also going to be congruent. So just to remind you, if I had two parallel lines cut by a transversal, alternate interior angles are inside the parallel lines and on opposite sides of the transversal. Alternate exterior angles are on the outsides of the parallel lines, but still on opposite sides of the transversal. Corresponding angles are angles that are in the same spot on the two different parallel lines. So for instance, this angle is above the parallel line and to the left. So its corresponding angle is the other one that is above the parallel line and to the left. Whereas, for instance, this one is below the parallel line and to the right, so its corresponding angle is going to be there. Finally, we have vertical angles, and vertical angles are made up by two intersecting lines, and it's their opposite angles. So these would be vertical angles, which are congruent. Here's another set of vertical angles, which are congruent. Part B asks, which angle pairs are supplementary? So we know that same side interior angles, same side exterior angles, and linear pairs are angle pairs that are supplementary. So same side interior angles mean they're on the same side of the transversal, and interior means inside. So these would be same side interior angles. They're not congruent, but they're supplementary, meaning they add up to 180 degrees. Same side exterior angles would be on the same side of the transversal, but outside of the parallel lines. So these are also supplementary. Finally, we have linear pairs, and linear pairs mean two angles that are adjacent to one another that are supplementary. So for instance, this angle and this angle are supplementary because they form a straight angle and they're adjacent to each other. Question 38 asks us, given line M is parallel to line N and angle 1 is congruent to angle 16, we need to prove that line P is parallel to line Q. So remember that there's multiple ways to do a proof. You can do a 2-column proof, you can do a flowchart proof, you can do a paragraph proof. I personally am going to do a 2-column proof. So I'm going to draw my line and split it in half, and I'm going to label statements at the top because that's what goes in the left-hand column, and reasons is what goes into the right-hand column. I'm going to tell you right now that there are multiple ways to do this proof, multiple ways. There's so many different angle relationships that you could use. So what I'm about to do is just one way, but please keep in mind that there are multiple ways. So the first thing I'm going to do is state that angle 1 is congruent to angle 16. And my reason is because this is given. So I know, as I drew on my picture, angle 1 is congruent to angle 16. My second statement, because there's nothing I can really do with that, is that M is parallel to N, and that is also my given. So I know that this line is going to be parallel to this line. I somehow need to show that I'm going to need to use this relationship. I'm going to somehow need to show that this line is parallel to this line using relationships with just one transversal. Because right now this angle has these two parallel lines, but it deals with two transversals. So I either need to take this angle and relate it to something over here or relate it to something over here. So what I'm going to say is that angle 1 is congruent to angle 9. So I can say angle 1 is congruent to angle 9. And the reason for this is because they're corresponding angles formed by parallel lines. So if I need to, I could write out that whole sentence. If two parallel lines are cut by a transversal, then corresponding angles are congruent. However, I can also just abbreviate this with the corresponding angles postulate. So we know angle 1 is congruent to angle 9. I can also see that I've got angle 1 is congruent to 16, angle 16, and angle 1 is congruent to angle 9. So I can put those together and say angle 16 is congruent to angle 9, which makes sense based off of my picture. So angle 16 is congruent to angle 9 is going to be the substitution property of congruence. And I can see this because I substituted this statement right here into step 3. So if I know angle 16 is congruent to angle 9, I can also see that these are alternate exterior angles. And if two lines are cut by a transversal such that alternate exterior angles are congruent, then we can prove that the lines are parallel. So we can go into step 5, which proves P is parallel to Q. And if you want to write that sentence, by all means go ahead and write it. Otherwise, you can write the converse of the alternate exterior angles theorem. So if you ever can't remember what the statement, the reason is, write out the sentence that you know. Again, if two lines are cut by a transversal, so these two lines are cut by a transversal such that alternate exterior angles are congruent, which angle 9 and 16 are, then these lines must be parallel. So question 39, we're given this diagram right here, and we're told that angle A is congruent to angle D, and AB is congruent to DE. Well, I can see that I've got a set of vertical angles right here, so I know that I'm going to prove that these two angles are congruent. And then I can see that these two triangles are congruent by AAS. We've got AAS. And therefore, I can prove CE is congruent to CB through CPCTC. So let's write out this proof. We have our statements, and we have our reasons. So I'm going to start with my given. So angle A is congruent to angle D, and the reason is because it's given. Additionally, AB is congruent to DE, and that also is given. Now, as I mentioned before, we have to look at these two angles right here, which are vertical angles. So we can say statement 3 is that angle ACB, so the one right here, angle ACB, and I can't say angle C because I won't know which one, so we need to use 3 letters. Angle ACB is going to be congruent to angle DCE. And the reason for this is the vertical angles theorem. Again, if you want to just write out what you're trying to say, that's fine too. So I could write vertical angles are congruent. Step 4, because I now have an angle, and a side for each of these, I can prove that triangle ABC is congruent to triangle DEC. Please remember that corresponding parts need to match up. So angle A corresponds with D, C corresponds with C, so ACB and DCE, and therefore angle B must correspond with angle E. So we know that these two triangles are congruent through the AAS congruence postulate. And then finally, once I've known that these two triangles are congruent, I can prove CE is congruent to CB through CPCTC. So CE is congruent to CB, and my reason is CPCTC. Corresponding parts of congruent triangles are congruent. And there's our proof. Question 40 says, given C is the midpoint of BE, AB is congruent to DC, AB is perpendicular to BE, DC is perpendicular to BE, and we need to prove that angle A is congruent to angle D. Well, basically what we need to do is prove that these two triangles are congruent. If C is the midpoint of BE, then we know that BC is going to be congruent to CE. We're also told that AB is congruent to DC. And finally, we're told that AB is perpendicular to BE and DC is perpendicular to BE. Therefore, we know that this is going to be a right angle, as is this. And we can prove the two triangles are congruent by side angle side. So in order to do this proof, I'm going to do a 2-column proof with my statements on the left and my reasons on the right. So I'm going to start with my first statement, my first given, which is C is the midpoint of BE. What I know about this is my given, and this tells me that BC is congruent to CE because a midpoint divides a line segment in half. So before stating all of my other givens, it's really good to work off of each given one at a time. My reason for this is going to be definition of a midpoint. All right, next thing, so I've proven that this is congruent to this. Next thing is I'm going to state my given, which says AB is congruent to DC. This is my given. There's nothing more I can do with this, so I'm going to move on to my last one, which is that AB is perpendicular to BE, and DC is perpendicular to BE. So again, this is my given. And what this tells me is that both angle B, so angle B right here, and angle DCE are right angles. So these two angles are right angles, and that's due to the definition of perpendicular lines. So if I know that these two are right angles, I then also know that angle B is congruent to angle DCE. And this is because all right angles are congruent. So now I've proven by side angle side that these two triangles are congruent. So we know that triangle ABC is going to be congruent to triangle DCE. And this is due to the side angle side congruence postulate. I am running out of space, but luckily we just have one left. And that is step 8. I'll write it right here. Step 8, we can prove that angle A is congruent to angle D. And our reason is because of corresponding parts of congruent triangles are congruent, or CPCTC. And that is the end of that proof. The last question we have is 41. And what it says is, below is a figure that will help you prove that the sum of the angles of a triangle is 180 degrees. The two lines are parallel. So we know M is parallel to N. That is basically our given. And we are not basically, but we are trying to prove that the sum of the angles of a triangle is 180 degrees. So here are 3 angles. We're trying to prove that the measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 equals 180 degrees. So we're going to write a proof for this theorem. The first thing I'm going to do, as always, is make my 2 columns, and I've got statements and my reasons. So I'm going to start out with my given, which is that line M is parallel to line N. Because line M is parallel to line N, I've got different sets of parallel lines cut by transversals. So I've got this transversal here and this one here. This tells me that angle 1 is congruent to angle 4, and angle 3 is congruent to angle 5 for the same reasons. So let's start with the measure of angle 1 equals the measure of angle 4, and this is due to alternate interior angles theorem. The same can be said about step 3, which is that the measure of angle 3 equals the measure of angle 5. This is also because of alternate interior angles theorem. If you want to say something along the lines of, if 2 parallel lines are cut by a transversal, then the alternate interior angles have the same measure, that's fine, but this might be easier. The next thing I notice is that these 3 angles right here make a straight line. So if they make a straight line, then I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is going to add to 180 degrees. The reason for this is that the sum of 3 adjacent angles whose vertices lie on a line have a sum of 180 degrees. So again, in case you can't read my handwriting, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equal 180 degrees because the sum of three adjacent angles whose vertices lie in a line have a sum of 180 degrees. Next, we know that if we were to substitute in, we know measure of angle 1 equals measure of angle 4. So in step 4, I'm going to substitute in measure of angle 4 for my measure of angle 1. I'm still going to have the measure of angle 2. And then I also know that the measure of angle 3 equals the measure of angle 5. So I'm going to substitute in for the measure of angle 3, the measure of angle 5, and this is going to add to 180 degrees. So step 5 is the substitution property of equality. And therefore, what we can see is that that was what we were trying to prove. Measure of angle 2 plus 4 plus 5. 2 plus 4 plus 5 equals 180 degrees. If you want to make this a good proof, we're actually going to switch the order so it matches what we're trying to prove. So the measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 equals 180 degrees, because that was what we originally said we were trying to prove. And I can see that I switched the order of 4 and 2. So that's going to be the commutative property of addition. So that ends Unit 1, Topic 4 of the exam review.